All right, hi kids. So I'm not here today. Um, as our normal routine, as we're doing these video lessons, make sure you're pausing and playing based on your speed. If I'm going too fast, pause it, go back over it. You can even ask questions with others that are in class. Um, there will be some stuff that I'm going to go rather quickly on. We'll go over it more tomorrow, but you will be doing it tonight for homework, so make sure that you're going back over this video. All right, so let's start off with a little warm up. I don't have a page. How about like page? I think maybe like I'm going to say 34 or 33, something that's open. And I just want you to draw this triangle. Draw this triangle with a K value, a scale factor of 4.5, and tell me what the new triangle's lengths are. Pause the video, and then I'll show you the answer. All right, so here we go. So here's the answer key. So for all your side lengths, W prime, W prime, I prime, W prime, G prime, and I prime, G prime, right? You get these values. And how do you get it? Well, your K value is what you multiply by. So for all these, you'll take this and you'll multiply by 4.25 every single time, and that's how you find your prime values. Again, scale factor is what you multiply by to get to your new shapes, side lengths. All right, so hopefully you got those, and your answer key to last night's homework was in the back of the book. That was bookwork. If you have other questions, you can ask those tomorrow in class, and I'll go over that. So here we go. Page 36 is where we're actually going to start like our first type of problem. I know it says warm up, but we're going to do together. So it says a poster of the tallest building in the world hangs in the hallway. The scale of the poster is 0.5 inch or half of an inch. That indicates that it actually equals in real life 45 feet. That's how they do things in the history books. Like when they put the map of the earth on there, clearly you can't have the entire earth on a page, but they scale it saying that each quarter inch equals, 28 miles or something like that. So this is what we call our scale, all right? It's telling you your scale factor, all right? Scale factor. So this is the height of the, excuse me, the height of the tallest building in the world. I have no idea how to say this. So it's in Dubai. Is about 3.25 inches on the poster. What is the actual height of that building? So this is your poster height. This is the poster, all right? It's important that you know what that is. What we want to find is the actual height of it. So to do this, what we're going to do first is we're going to use this scale. And how we're going to set it up is this: 0.5 inches over 45 feet. Now, the reason we do it like this is what we're going to do is we're going to create equal ratios, or what we're going to do is basically create a proportion. All right, a half of inch equals 45 actual feet. So what we're going to do, half of inch is the poster. So poster is on the top and actual is on the bottom. So they tell us that the poster in the school is 30.25 inches. So where are we going to put this 30.25 inches in this proportion? Well, the 30.25 inches is going to be up in the top. And what we want to find is the actual height of this building. And the actual, what we want to find, is going to go down here. We're going to call this X. The actual will always be your X, or the side we're missing, the length we're missing, we'll call X. So how do we solve this? Well, anytime you're solving a proportion or two ratios, we cross multiply. So we're going to cross multiply here. X times a half is 0.5x equals, and now you're just going to go 45 times 30.25, and you get 1,000. Come on, stay there, buddy. Why is that moving? Sorry, excuse me. 1,361.25. All right, and now we divide by a half. Divide by a half. And that's also known as multiply by 2, and you're going to get 2,722.5. And because we're finding the actual height, that's in feet. And that's how tall it is. That's how tall your poster is. See that? Now it says the height of the tallest building in the United States, the Willis Tower, formerly known as the Sears Tower. Don't ever call it the Willis Tower. It's always known as the Sears Tower. is 16 inches on the poster. What's its actual height? So what we do is we'll use the same ratio again. 0.5 over 45. Oh, man. Computer's acting really good today, kids. All right, so the poster is 16. 16 goes on the top, actual goes on the bottom. All right, it's the same exact thing as what we did in the problem above. Poster top, actual bottom, and we'll cross multiply again. So we get 0.5x equals 16 times 45. And you're going to get 720. Divide by 0.5. And you're going to get x equals 720 divided by. You'll get 1,440 feet because we're talking about actuals. So now, how much taller is the building in Dubai than the Willis Tower? Well, what you're going to do is you're going to take the first value we got, 2,722.5, 2,722.5, and to find the difference, how much taller, we're going to subtract that from 1,440, and you will get you're going to get 1,282.5 feet. And that's how much taller it is. So it's almost double the height of the Willis Tower, which is kind of crazy to think about it because the Willis Tower is the tallest building in America. And in Dubai, they have a building that's almost double its height. It's crazy. So here we go. So today what we're going to do is we're going to use scales like you used there. And we're going to use those scales to help us determine if two shapes are similar. So we're going to use the distance formula to find the length of a segment, and then we're going to find the side lengths of triangles to determine similarity. So what we're going to do is we're going to expand our understanding of dilations, and we're going to talk about similarity, which is almost identical to dilations, but there's a little thing that's different. So on page 38, you have already written down these notes. You've already written down these notes, all right? Now, if you want to write them down again, you can, all right? But you do not have these notes. And the ones in green, I really want you to take down. All right, I want you to pause. After you've written them, press play and we'll talk. So, all right. So if you look, dilation, similarity, they're very, very similar in definition. So if we want to talk about things that are the same, all right, their corresponding angles and angles are congruent. This and this are the same in both similarity and dilation. All right, the measures of their corresponding sides are proportional. That's the same. Proportional, all right, means that they have a scale factor. All right, proportional means they have a scale factor or K value. All right, you want a K value. The K value is what tells you how much it's growing or shrinking by. The thing that's different between dilation and similarity is this last one. All right, in dilation, the orientation is the same, meaning that your original image and your final image haven't rotated at all. It's in the exact same position. Like angle A is up in the top right, angle A prime is in the top right. All right. In similarity, rotation, R-O-T-A-T-I-O-N. Sorry, I'm writing with a highlighter, probably not the best. Rotation is okay. And that's the thing. Rotation is okay, meaning that we now can look at shapes. And after they've been turned a little bit, we can still determine if they are in fact similar by checking if corresponding angles are congruent and their corresponding sides are proportional. And this word corresponding, oops, sorry, not congruent, corresponding, you see it here, and here I've been using it over the past couple of days. Corresponding means matching. All right, it's the sides that match up with each other. And we'll see what that is. So our first example is on page 39. Now you're going to notice, you'll be like, whoa, Mr. Quammen, you already did this. You already did page 39. I kind of did. So here's the deal. All right, it's very difficult to write on my computer. So I've already kind of written out some stuff, but I want you to see what's going on here. So example 1 says, use the definition of similarity in terms of transformation to determine whether the two figures are similar. Explain your answer. Well, first thing, right, in the definition of similarity, in the definition of similarity, you have to talk about the angles. Like, are the corresponding angles congruent? Well, here's the deal. If you look at your figure, do you see any arc marks? No. So what we're going to do is we're going to say we're not going to think about the arc marks. Arc marks are okay right now. Angles are congruent, whatever. What we're going to do is we're going to look at sides. Excuse me. Are the side lengths corresponding? Do they have a common scale factor? So how do we do that on a graph like this? Well, we're not going to look at their coordinates. We're not going to do the coordinate thing where, oh, it has a scale factor of 2, blah, 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 blah. All right. What we're going to do is we're going to look at their side lengths. Length is important in similarity. You have to know their length. So how do you know the length of a shape that is slanted? Like, I can't count a slanted line. Like, for instance, I can't count AB, because it's on a diagonal. So how do you do that? Well, you use the distance formula. And this is the distance formula right here. What it is it's basically the Pythagorean theorem, but it's the distance between 2 points, any 2 points. Now, here's the deal. You're going to have to use this distance formula in this problem and the next problem 6 times. 6 times completely. So what I'm going to do is I'm just going to kind of walk you through the distance formula a couple times, and then hopefully you'll pick it up and remember what you've done, and you can check and verify that your answers are the same as mine. All right. So the first one is the one that I highlighted. All right. When doing similarity, it doesn't matter what shape you start with. All right. It doesn't matter what side you start with. You just got to make sure that you are finding their lengths. All right. So I'm going to show you what you do. In the distance formula, it's the square root of x2 minus x1 squared plus y2 minus y1 squared. So what I'll do is I'll start with AB, and over on the side, I'm going to list out all of AB, which is the small triangle side lengths. So I got AB, BC, AC. And what I'm going to do is I'm going to start with one big square root going almost to the entire coordinate plane. And what I'm going to do is I'm going to start with the formula. Now notice what I've already done beforehand. All right. These coordinates are not on your graph. You have to put them on there yourself. Putting them on there beforehand really helps you out to make this process go much smoother and have less errors in it. So, all right, back to what I was doing. So A and B. So we want to find the length of this segment. So what we're going to do, the distance formula says this. You're going to go x2 minus x1, which means just take your two x's and subtract them from each other. Order does not matter. Order does not matter here. So I'm just going to go A and B's x's. So I'm going to go -4 minus 1. So watch, I'm going to go parentheses -4 minus, and then 1. Close your parentheses, and we're going to square it, plus, that's parentheses again, that's a parentheses, and now we're going to go y2 minus y1. So again, I'm going to take the y value of the A, which is 1, put a minus sign, and then our B value's y value is 2, and we square it. All right? Now, this right here is great work. Now what we're going to do is we're going to let our calculator do a little work for us. All right? And what I mean by that is we actually are going to leave our answer, and I'm going to show you this. We're going to leave our answer as a square root. You see this? We're going to leave our answer as a square root. It's in the square root. What we really care about is this guy right here. Oops, wrong color. That guy. So what you're going to want to do is you're going to want to take this with the parentheses, with everything, and you're going to want to put that number every time in your calculator. So you're going to want to go parentheses, -4 minus 1, close your parentheses squared, plus parentheses 1 minus 4, close your parentheses squared. So you're going to want to put all that in your calculator, hit enter, and you should get 34. All right, so you should get 34. Now, all right, as you keep doing this, all right, as you keep doing this, you're going to end up getting all of these different, radicals here. All right, so if we were to keep going, all right, so good, square root of 34, you're going to leave that as an answer. All right, leave that. Don't turn that into a decimal. Don't turn that into 5 point something. All right, leave it as the square root of 34. That's the best answer you could possibly do. So, all right, let's do BC, and then I'm going to let you try to see if you can calculate the rest of these, all right? So BC is, let me get rid of that. All right, here is BC. So BC is right here, boom, all right? So again, we're going to start with a big square root, all right, big square root. and we're going to go take our x's. So b has an x of 1, c has an x of 2. So we're going to go parentheses 1 minus 2 squared plus, all right, now here's the fun part, 4 and negative 2. Now watch this. You're going to go 4 minus, because the formula is x or y minus y. So we're going to go 4 minus and then negative 2. So watch what happens. I'm going to put another negative and a 2, close it up and square it. Now, what will happen is when you go 4 minus negative 2, when you subtract a negative, it becomes positive. So that's the only time a plus sign occurs in your problem is when you subtract the negative. So now, just like the last problem, we're going to take this number that is underneath the square root and we're going to calculate what it is. Do not take the square root of it. Just leave your radical on there. Clearly it's going to become 37. So let's see. You should end up getting 37. All right. So what I'd like you to do is try to calculate these all by yourself and make sure that you're getting the same values. All right. For X, Y, and Z. All right. Pause it. Make sure that you calculate them and then play them up again, and we'll keep talking about it. All right. All right. So here we go. Now that you have all 6, we got the square root of 34. Come on, buddy, go away. We got the square root of, leave that there. Really? All right, we got the square root of 34, square root of 36, and square root of 45. That's a small triangle ABC. We have the square root of 136, square root of 148, and square root of 180. That's the big triangle sideline. All right, we got them all. Now, the whole part about this, and some of you are like, well, what are we doing? Like, we just calculated side length. That's 8th grade stuff. That's freshman year stuff. Why are we doing it? Well, here's the real deal, all right? What we have to do is we have to now say, all right, if these are my side lengths, notice I don't know what A prime, B prime, C prime are, or X prime, Y prime, Z prime. Clearly, these two triangles are similar, meaning that they don't have the same coordinates or same vertices. They're different vertices. They're different numbers, letters, all right? So what we have to do is we have to categorize these different square roots based on size, all right? Because that's how you determine what sides in triangle XYZ and triangle ABC, which ones match up. So what we're going to do, all right, what we're going to do is we're going to categorize them as small, medium, large. So in square roots, all right, even though it's a square root, the number underneath the square root determines how big the number is going to be. So square root of 34 is actually the smallest number in comparison to all 3 of the sides in triangle ABC. Square root of 37 is the medium side, and then square root of 45 is the large side. All right, so using S, M, and L helps us categorize which sides are small, medium, and large in comparison. We're going to do the same thing with triangle XYZ. So I got 136, 148, and 180. So 136 is your small, 148 is your medium, and your large is 180. You see that? So what you're going to do now is after you've categorized them small, medium, large, we now are going to determine what our scale factor is. All right, we're going to determine if they're in fact similar because they're going to give us a common scale factor. So to find our scale factor, or if there is similarity at all, after saying you're small, you're the medium, you're the large, small, medium, large, what we're going to do is we're going to set up our ratios. All right, small over small, medium over medium, and large over large. All right, and what we're going to do is you have to choose an order. All right, you have to choose an order. Hi, honey. Hi. Come on, let me finish this. All right, and what you do is you just choose a triangle. So what I'm going to do is I'm going to set up a rule, and I'm going to say, all right, the top is going to be triangle ABC, and the bottom is going to be triangle XYZ. And we follow this pattern the entire time. All the small, medium, large sizes need to be ABC. All right, all the small, medium, large sizes for triangle XYZ need to be at the bottom. What we're going to do is we're going to set up this ratio. This is what it's going to look like. You take your small size for ABC over your small size XYZ. Medium over medium, large over large. And what you're going to do is you're now going to put them in your calculator like you can see over here. You can see that in my calculator, and they're going to give you a value. It's 0.5. 0.5 is your K value, and because they all have the same K value, they are in fact similar. And that's how you determine similarity. You have to know your side lengths, determine which one's small, which one's medium and large. And to determine if they are in fact similar, they must have the same scale factor. All right, and that's what we just did. All that hard work using distance formula was just allowing us to determine, do they give you a common ratio of a half? All right, so some of you are like, oh my gosh, that kind of blew my mind. Well, we got another one here. All right, so flip the page, and here we go. Now, all right, I've given you triangle HJK. I've given you all their lengths. All right, that's the small guy. I want you to find the lengths of triangle PNQ. All right, now notice what I've already done here to kind of save some time. What you want to do is always find your coordinates first and then use your distance formula. So I want you to try to find the 3 side lengths of triangle PNQ, and then we'll determine, are these 2 triangles in fact similar by setting up a scale factor. So pause it and then play it when you finished. Okay, here we go. So triangle PNQ should have gotten you the square root of 145. Side NQ should have gotten you the square root of 325. Thank you. And triangle PQ is 306. So we have our 3 sides for triangle PNQ. We have our 3 sides for triangle HJK, which I've already found for you. Now what we want to do is look at each triangle individually and determine which side is the small, which side is the medium, which side is the large. So small is going to be square root of 145. Your medium is going to be square root 306, and your largest side is going to be the square root of 325. Now in triangle HJK, if I look at it, the small side is going to be the square root of 25. The medium side is going to be the square root of 34, and the large side is going to be the square root of 53. All right. So now, looking at that, now that we've categorized them, what we're going to do is we're going to determine, are these 2 triangles, PNQ and HJK, are they in fact similar? So what I did is I set up a ratio. All right. I did triangle HJK over triangle PNQ. All right. And I kept all the sides the same. All right. Now, if you're looking at it, you're like, why did he do it? How did he get those numbers? All right. All right. What I did is I took my 2 small sides and I set up a small ratio, HJK over PNQ. You could have flipped it. It doesn't matter. I took my medium sides, HJK over PNQ, kept the same order, and then I took my large sides for HJK and PNQ in the same order. And what I did is I now divided them. And for the small side, I got a ratio of 2.4. For the medium side, I got a ratio of 3. For the large side, I got a ratio of 2.4. Now, what we're looking for is a common scale factor. Do we get a common scale factor here? Well, no, because 2.4, 3, and 2.476, blah, 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 are not equal. Therefore, these 2 triangles are not similar. And that's what you have to look for. If you do not get a common scale factor, they are not similar. And it only happens after you've identified what's your small, what's your medium, and your large, and then set up your ratios to figure that out. All right, so here we go. What I want you to do, and you should have already gotten this paper, is we're going to do 2 more problems, all right? This is your additional notes. So now sometimes I'm going to ask you to find side lengths. Now that takes a lot of time, so I'm not going to ask you many of those, but I'm going to actually give you side lengths. And here's the deal. I'm going to give you a similarity statement, which I have identified up here. A similarity statement tells you what sides and what angles correspond with each other. Order matters, right? Order matters. It is crazy important when you write a similarity statement and when you use a similarity statement that you identify your order. So here we go. The question says, use what you know about similarity and proportionality to find side HJ. So I'm going to call HJX. Now here's the deal. Many kids will say, oh, I can tell you what sides must match up and all that good stuff. But just by looks, it doesn't help you. You must take those sides from the similarity statement and determine what ratio you should make to find your missing side. So what you're going to do is you're going to start and you're going to say, all right, the side RS or 10 must match up with what other side? So what I do is I look at my similarity statement, and RS is the first two letters. That means it must correspond with GH, the first two letters, which is 15. And what I'm going to do is I'm going to set up a ratio, 10 over 15. Now, some kids are like, I want to set it up 15 over 10. It doesn't matter. You just need to put them in the same order for the second set of ratios. So I just matched up RS and GH as corresponding sides. So what I want to do is I want to see, all right, 8, what side does 8 match up with? Well, many of you are like, well, duh, it's got to match up with X because that's the only other side you have. But I want you to get practice using your similarity statement. ST is the second two letters, and the second two letters match up with HJ, which is X. So we're going to go 8 over X, and that is your ratio. And we're going to use this ratio to find our missing side link, like what we did with the scale of the building in Dubai. We're going to cross multiply. So we're going to get 10x equals 120. Divide by 10, and x equals 12. And that's how you do this. And that's how you do that right there, right? So you gotta look at the similarity statement to help you determine this. Now, the similarity statement will also tell you what angles, thank you, honey, what angles are in fact congruent. All right. Now notice angles aren't on here, but I could put angles on there if I wanted to, but I didn't need to. In number 2, it tells you, hey, the following triangles are similar. Great. But unlike the last problem, it doesn't give us a similarity statement. I want you to create that. All right. I want you to create the similarity statement. So how do you create your similarity statement? Well, it's easy. First thing you do is order doesn't matter of what triangle should come first in the similarity statement. I just go in order of, hey, what's the first one left to right? And then, again, order doesn't matter on the first triangle on what letter comes first. So me, I go in alphabetical order. D, E, F. That's how I'm going to write the first one. D, E, F. Now, order is crazy important on the second one now. Because I chose D, E, F, I need to find the corresponding angles or sides that match up with triangle GHJ. So what I do is look at the arcs. D, E, F. D has 2 arcs, E has 3 arcs, F has 1. So we want to find that same pattern in this triangle over here to the right. So we want 2, 3, 1. That would be J, H, G. And that is the only order that you can put them in if D, E, F is your first triangle. All right, that is their correct order. Now, if you were like, oh, I want to do it a different way because I'm a rebel and I want to do it like that, and I want to go E, all right, E, F, D. All right, I want to do triangle EFD is similar to triangle. Now, if you did it that way, E, F, D, well, E has 3 arcs, F has 1, D has 2. So you just have to match it up that same way. 3, 1, 2. So it would have to be H, G, J. So triangle H, G, J. So understand, there's always 3 ways to do these similarity statements. You just need to make sure that you follow order and look at the angles in order to help you out here. So now that we did that, now we're going to find the missing side length of GJ. So GJ, I'm going to call that X. Now, I will tell you this. I kind of got excited on the first one and I just wanted to do it. I'm like, oh, cool, finally we're doing this. I'm going to show you this. Sometimes, for me, it really helps me out to set up my ratio starting with my variable, because clearly we're trying to find that. We want to find that side length, all right? So here we go. What I want to do is I'm going to find the value of X, all right? So X corresponds with what side here? Now, you can go back to the similarity statement, but what I like to do is, since I have angles in this problem, all right, what I'm going to want to do, hi honey, thank you for my code. You're the best. Why don't you go drink some milk here? Okay. There you go. You're so cute. All right. So X is in between the 1 arc and 2 arc side. So I look at those things, those little visual features to help me see what sides match up. So X is between the 1 arc, 2 arc. So 16 is between the 1 arc, 2 arc. So X over 16. Now, if you look, my order is triangle GHJ is on top and triangle DEF is on bottom. So you got to keep that same order. So this right triangle is going to be on top. All the sides there are going to be on top, and on the bottom is going to be triangle DEF. So now what I do is I got to say, all right, 15. 15 clearly is going to go to the top because it's on the same triangle as X. What side does 15 correspond with? Well, 15 is between the 1 and the 3, and so is 20. 20 is between the 1 and the 3 arc. So now that we set up our ratio, now we can solve for the value of x. We're going to go 16 times 15 and 20 times x. So we're going to get 20x equals 16 times 15 is, I believe it's 130. Nope, sorry, 240. And we're going to divide by 20, and you're going to get x equals 12. Oh, wasn't that our answer on the last one? It was. Look at that. So x equals 12. So it says find the side of GJ. So GJ equals 12. Now, ready? Yes, baby. Oh, thank you so much. Come on, go drink some more milk. Be right there, okay? All right, so here's our last part. Now, it says find all the missing angles. Now, this is like a replay of 8th grade and freshman year. All 3 angles of a triangle do what? Well, they add up to 180 degrees. So if you know these 2 angles, 20 and 85, to find the third missing angle, D, you're going to go 180 minus 20 minus 85, and you're going to end up getting 75 degrees. So this angle is 75 degrees, which now, knowing all 3 of these angles in triangle DEF, we can find the angles in triangle GHJ by looking at the arc marks. F has 1, so does G, so G is 85. J has 2, D has 2, so J is 75. And then lastly, H is 2, E is 2, so H is 20 degrees. All right? All right, your homework tonight is page 45. I would like you to do 9 and 10, and then I want you to complete the back side of the worksheet, okay? So really, it's only 4 problems, all right? But 9 and 10 are a little brutal, but please try your hardest, use your distance formula, and look back at these at this video lesson if you have any questions. Have a great day. Be good to the sub.